Alright, so this should be your first flipped classroom video, so congratulations for logging on and seeing the first video. Should be really exciting for you. So this is the scientific method, so this should have been your homework. So hopefully you have the handout in front of you, so make sure you have that so that way you can go through this in a timely fashion. If not, you can always press pause or rewind, or you can listen to my voice again if you don't find it too annoying. Okay, so we're going to talk about the scientific method. Did you know that when you're using the scientific method, you must use your own words? Really? I didn't know that, Miss Dudek. Yes, you do need to do that. You cannot plagiarize your stuff, meaning copy it from the book. Your neatness counts, so you can always type your lab reports and things like that if you really want to, but make sure that you're using your best handwriting, because if I can't read it, it's going to be wrong. So with your scientific method foldable that you have in front of you, the first step is the purpose. The second is research. The third is your hypothesis. The next is the actual experiment. This is the fun part. And then your graphs or data analysis, and of course your conclusion. So it's broken into these 6 steps for you. If you can't get all of these done in the time that I'm about to switch the slide, you can always pause this video if you need to. The first step is purpose, or the problem, if you've previously learned about the scientific method. You need to pick a question to be tested. Yes, you need to write this down on your foldable. Must be able to be answered by experimenting and measuring. You don't need to write that one down, just the first one. The second one is research. So collect some information. You can use the internet, interviews, books, prior knowledge, observations. You can always search online, or you can, find a book that has to do with the problem that you're trying to research for your lab. Or you can always use the science book. There's plenty of them in the classroom that you can check out if you want to. Yes, you need to write all that down. Hypothesis. So this is your educated guess because you've already done some research. You're not going to go into an experiment blindly and think, I think the sun is going to shine more and the plant is going to grow more because I'm putting it in a shiny place. No, you need to research, okay, what makes a plant grow, things like that, so that way this is actually an educated guess, not just a random guess. It is what you think will happen during the experiment, not what Miss Dudek thinks, not what your best friend thinks, not what the book thinks is going to happen. This is what you think is going to happen because you're going to be doing this experiment, whatever experiment you may choose to do this year. So you need to make sure that you're invested in it and you actually, this is your guess. You can use the if-then statement if you want to. Sometimes it's a little bit easier to go back and check your work and, kind of tell what you were actually guessing. But you don't have to, just as long as it's kind of in that same format. It's okay if your guess is proven wrong. That just means that you learned something. So no problem if, you're completely off. That just means you can go through it again with a better guess if you want to. Step 4 is the experiment. So this is what you're going to test and actually collect data on. You're not just going to do a fun experiment and then say, voila, Miss Dudek, I did it. Of course, this is the fun part in the scientific method. Alright, you're going to design a controlled experiment. So this is still under experiment on your foldable. You're going to include a detailed list of materials, always, always, always. You're going to include the amount and type, so you're not going to say dirt and sunlight and a plant. You have to be very specific so somebody else could do your experiment if they wanted to. You need to do step-by-step procedures with numbers or bullets, so that way, people can walk through it, just like this for this fruit salad. It wouldn't be a good recipe if nobody said, oh, you're going to put some bananas in there. No, we need to know how many bananas you're going to put in there. In this case, this one says 2, and then 1 cup of fresh strawberries. It's not going to say, just put a couple strawberries in there and a couple orange slices and maybe an apple. Or else you're going to wind up with a whole apple in your fruit salad, and that's not going to be very good. Alright, so moving on with your procedures and everything like that you need to write down for your experiment, you also need to figure out what the variables are. There are two types of variables, and you've probably heard of this before. One of them is what is being changed, and the one is what is being constant in this. And sometimes you've heard of this as independent and dependent variables, or you can write down control variable and also the manipulated variable. So manipulated is also called the independent, if you've ever heard of that before. This is the variable that you change on purpose. So let's just say you're doing an experiment and you have two plants and you want to see which one is going to grow better. So you'll have maybe the same type of soil, the same plant, the same pot, and things like that, and you're only going to change one thing, so that might be the amount of sunlight that you're giving both of your plants. Now you would only put one of them in the sunlight for longer than the other one, so your manipulated variable would be the sun, because you're changing it on purpose to get a result. You should only have one per experiment. So let's just say, again, you're trying to see which plant is going to grow, higher or more. You're not going to change the amount of sunlight and also the amount of water you give them, or you're not going to change the amount of sunlight and also the type of soil, because then you don't really know what is causing the plant to grow more than the other. So you always want to have just one independent variable. The next one is the responding variable. This is also called the dependent variable. This is a variable that changes because of the manipulated variable. So again, sticking with the same experiment, if you put one plant in the sunlight longer, again, the amount of sunlight is your independent or manipulated variable, but the amount that the plant grows would be your responding variable or the dependent variable, because it's changing because of the amount of sunlight. This is usually what is being measured during the experiment. So again, at the beginning of the experiment, you would say, I want to see which plant is going to grow more. Well, that would be your responding variable, because that is what you're trying to measure. Oh, well, here we go. Plants grow taller and stronger when given Miracle-Gro fertilizer. So this might not be the sunlight one. This might be just changing the fertilizer to see which plant is going to grow taller. You can also have one where basketballs are inflated with more air and see if it will bounce higher. All right, and your data. So the next flap on your scientific method foldable. You must be honest, clear, and accurate. So you can't lie on your data just because you want your hypothesis to be correct. It should be repeated. So if the data differs with each trial, is this, going to have a bearing on your experiment? Is it going to change your hypothesis? Does it make your data wrong? Things like that. So make sure that you're always doing this experiment a couple of times, so that way you can kind of see, what things are occurring more. You also need to write down your observations and data as you do the experiment. So make sure you have all three of those things down on your data flap on your scientific method foldable. Interpreting the data. So step 5, you can always have table graphs and charts. You can use this to compare the data. And finally, step 6, conclusion. This is basically your final answer. You'll carefully examine the data and the graphs and then make your conclusion based off that. You also need to answer the question always, did the data support your hypothesis? So was your educated guess wrong? Was it right? And if it was wrong, how are you going to change it? Your conclusion, again, after collecting and interpreting the data, always has to be 1 to 2 paragraphs. So I don't want you to just say, I was wrong, period. That tells me nothing about your experiment. Or I don't want it to say, I was right, ha, blah, blah, blah. Okay, you need 1 to 2 paragraphs, so be specific, elaborate on your experiment, so that way we can all get a clear understanding of what you did and what your conclusions were from the experiment. So did you get the results you expected? And you can always pause if you want to read through this. So these are just some questions that you might want to answer in your conclusion, so that way you can get that 1 to 2 paragraphs. And this is very important, especially if you're working with a partner. The last thing at the bottom, the note down here, 2 different people can interpret the same data in 2 different ways. So if you're working with a partner and they're saying, well, I think this happened, and you're thinking in your head, well, this person is crazy, I don't think it happened that way, you can always write down different conclusions. You don't have to agree all the time. So, your choices for doing these questions are hypothesis, manipulated variable, responding variable, observations, and conclusion. So, number 1, a prediction about the outcome of an experiment would be what? This is when you're thinking about it, FYI. Okay, so hopefully you're right. It was hypothesis. What you measure or observe to get your results. And hopefully you were right on this one too. That is your observations or responding variable. Number 3, statement that sums up what you learned from an experiment. This one was an easy one. That is your conclusion. A couple more. The one thing that is changed in an experiment. So what are you, in fact, changing? That would be the manipulated variable or independent variable. What the person performing the experiment sees, hears, feels, smells, or tastes, and this one's easy too, your observations. And hopefully you got a feel for all that. Alrighty, give an example of when scientists have changed their conclusion or theory. So what you need to do is write this down. This will be your ticket in the door or your warm-up when you get to class tomorrow. So make sure that you have this down. So that way we can discuss it when we get into class, because I'm sure you guys have some theories or conclusions that we have today that people have been changing over time in science. So I hope you enjoyed your first flipped classroom video. Most of the time they're not going to be this long, I promise. But hopefully you got your scientific foldable done. If not, you can always rewind, pause it, things like that, and watch it again so that way you can get that done. You know I'll be checking it when you come into class tomorrow. Have a great evening.